So it's good to see that Tom's as good at table football as FANUC were actually on the pitch. Did you play that game we played against
no,
you, Andy?
I didn't, Paul. No, absolutely not.
You might have won if you'd have participated. You never know.
I doubt it.
Okay, great to thanks for joining us today.
Yeah.
These are the 3 demonstrations that we're going to see.
Yep.
Now the first one, for those that haven't been listening to the stream so far, is going to be the aluminium, isn't it? And what we're going to do is we're going to run the machine and we're going to talk about the demonstration as it happens.
Absolutely.
Once the aluminium's done, we're then going to talk about the cutting tools, back with the guys. We're then going to cut the mild steel, and then we're going to cut the stainless. So that's going to happen throughout the next sort of 40 minutes or so. So, Andy, do you want to press cycle start on the machine? So, as we're cutting this demonstration, I mean, the first thing I want to say to you is that the RoboDrill, over 200,000 machines installed worldwide. I mean, why is that an incredible...
Well, it's pretty impressive, isn't it, for any machine tool to be sold that many. But they're so reliable and rigid, and customers just keep coming back for more, so we love it.
Yeah, okay. Now, let's talk about this demonstration. What's happening? Tell us about some of the features that we're cutting and what we're doing.
Well, as you can probably hear, we're driving this machine pretty hard. We're cutting aluminium on the 10K spindle, which maybe we wouldn't choose to do ordinarily on a 10K spindle due to the torque curve that we've got. We've got a lot of torque, very low down in the rev range for cutting steels, but higher up the rev range we don't get that much torque off this spindle, so we've had to alter our approach a little bit on this aluminium piece.
Okay, so what you're really saying is that you do have the 24,000 option. Would we be able to cut this demonstration faster in the event that we had that too?
Yeah, more than likely.
Okay, now the features that we are machining, are they representative of what would happen in a modern machine shop?
Yeah, they are. I mean, we've got some facing, some shouldering, peripheral milling, and then pocketing using some volumetric type strategies. So yeah, typical features, drilling and tapping as well.
And when you're machining a part this quickly, because that's what the RoboDrill's been known for.
Absolutely.
What does it come down to in the machine? What are the features that enable it to generate these speeds? Really,
in terms of the control, is a fundamental part of what this machine can do. We've got a 1,000 block look ahead on this machine, so when we're doing very small linear moves, so the trachoidal pass that you'll find in pocketing strategies, we need that look ahead so that the machine can anticipate those moves early and keep the feed rate up going around those tight curves.
And does it have any impact or any bearing on the finished part when you're cutting this quickly? Because of course with parts like this, you know, they need to be precise, the surface finishes need to be exceptional. Do you achieve all of those even at such great speeds?
Yeah, well, we can sort of split it down to 2 parts normally. We have the roughing. We have the roughing that's split out away from the finishing, so we can alter the machining mode depending on what we're doing. So roughing, we'll have a lower quality mode where we can drive down the cycle time slightly. Finishing, we'll maybe switch to a higher precision mode where we can stick faithfully to the program toolpath and achieve those nice tight finishes and highly accurate parts.
Some of the features on these machines that are really, worth noting when it comes to the speed is the tool change time.
Absolutely.
Now, all very well if you're cutting a part quickly, but if your tool change is slow, then you're losing in one area what you gain in another, aren't you? So talk us through what we've got here.
Well, the tool change time on a RoboDrill is legendary. This is an advanced machine, so this is the fastest tool change time that we can do on a FANUC RoboDrill. Tool to tool, adjacent pockets is 0.7 of a second, and cut to cut is 1.3. So we're really cutting
0.7 of a second.
0.7 of a second adjacent tools.
So where's that really going to score then? You've got 21 stations in here. So if you've got a lot of tools on a job, that's really where you're going to make those savings.
Yeah. So you'll see on the later demo, we prepare a hole for say an M16 cap head fastener where we've got three tools going in succession. So in adjacent pockets, if you think about your programming strategy, one tool comes in, drills the counterbore, then the drilled hole, then the chamfer. So tool change time is paramount.
Okay, now what's coming up? We are talking now about the aluminium demo that's happening, but we are going to see the mild steel being cut and also stainless steel, and we're going to see the different strategies that happen on all of these. So it's going to be a fascinating few minutes in front of us. Now, this particular aluminium demonstration, how long does it take on the machine, Andy?
It's about 7.5 minutes.
And in your opinion, as an applications guy, as a guy that programs these, you're looking to show our audience something that really excites them. So what are the areas on this demonstration that are great?
I think in the aluminium, we've got to bear in mind that we are running it on a 10K spindle. So I think it's the different strategies that we've employed to make use of that torque low down in the rev range. So we've used slightly bigger diameter cutters than we maybe ordinarily would do on an aluminium part. We've got a big 63mm shoulder mill in there that just rips through the material. But we're down in the rev range where we get that torque to really drive it and get nearly 1,000 cubic centimetres of material off that.
Really?
Yeah.
Okay. Now, it sounds to me you obviously know a lot of what you're talking about. How do you find it when you go into the marketplace and talk to your customers? Are they aware of some of the techniques that you're talking about, or do they have the knowledge that you have? Isn't that part of this?
I would say I think they definitely know their own parts, and that's good. But maybe they don't know some of the technology within the RoboDrill that can help them get even more out of their parts. So we may be able to help them think slightly differently, utilise the machine in a slightly different way to achieve faster cycle times, and that's what we're here for.
Okay, now we are going to talk, as I've said already, if you've just tuned in, we want your comments really. We want to know what you think about this machine and the BBT30 spindle. It's going to get really exciting as the show unfolds when we start cutting stainless steel. There's a fantastic U-drilling operation on it. But as we go through each part, we're going to look at how the machine performs on each different material. The final question for you before we go over to the guys and talk about the tooling is going to be, when you're looking at aluminium, there's a lot of swarf being generated.
Absolutely.
So how do you cope with that on this machine? How do you get rid of it and evacuate it?
Well, we have a rather low swarf management system here. We've got it's an entry-level source management system. We've got internal wash bars within the machine that wash those chips out via fluid coolant. So we try and evacuate as much swarf as possible. Being an advanced machine, it does have a better swarf evacuation level than, say, a standard machine. It's slightly different designs to guards, pyramid guards, etc. So swarf doesn't stick.
So it's effective?
It is effective, yes.
Good.
Absolutely.
Okay, so when we come back and when I'm with Andy shortly, we're going to be actually cutting this piece of mild steel. But in the meantime, we're going to learn a little bit more about the tooling that's used on this demonstration. Back over to you guys, where you're joined by ITC.
Yes, thank you very much for that, gents. Little do you know, actually, Andy, in the rehearsals before the event, has been dancing, so hopefully we'll get him to do some moves a little bit later on in the show. Right, okay, we're joined by Paul Enzer from ITC. Paul, I've got a question for you. So can you tell us the difference between a face and taper and the BBT30 before we begin and get into the details?
So the term BBT refers to a big plus spindle. Big Kaiser is an amalgamation of two companies, Big Die Shower in Japan, who actually make the gauging to make the spindles, and then they make the actual spindle nose tooling to go with it. So to actually be a big plus spindle, it can only be if it's gauged by the Big Die Shower. So a lot of people talk about face and taper, but Big Plus is the actual true genuine article, if you like.
Okay, so if we move on to the tools themselves, the face mill VHSC doesn't exactly roll off the tongue, does it? But it's what I call a lozenger face mill. Deep depths of cut. We're looking at 25mm step over, 5mm depths of cut. Again, on a 30 taper machine. It's impressive, Paul.
Yeah, well, most importantly, it's combining the 50mm diameter of which is in effect a shoulder mill rather than a face mill, with the Big Plus contact to make it very stable and rigid on the machine. It's the latest generation in the Whittier shoulder mill series. It is a balanced body, which is very important, obviously, when you're dealing with small diameters spindles with large diameter tools, that it's all balanced. So the tool is actually balanced. The inserts that come with it have various radius sizes with inside one body capability. But that's the primary tool for removing most of the stock.
Yeah, there's a tool on this demo I haven't seen as part of your stable before. This one here, actually, the solid carbide tool with the gashes, with the chip breakers.
Yeah, so nowadays a lot is made out of trachoidal milling and the trachoidal milling method, taking deep depths of cut with a very shallow step over. This will obviously produce a large needle formed swarf, and more of the fact that the machines have problems getting rid of that swarf and the swarf management system. So what we've done is taken a 4-flute aluminium geometry capable of very high rapid metal removal rates, but then we've introduced a chip breaker into the flute as well. This breaks up the swarf, makes it more manageable for the machines to actually use it through the conveyors.
Yeah, and you can use that whether you're doing the OD of a part, or it's better in things like pockets, isn't it, where you're not going to choke the tool going into a corner. Yeah,
there's lots of different descriptions depending on the CAD software that you're using. So people call it volume milling, people call it trachoidal milling. Whether it's internal or external, as long as it's in that method where you're taking a deep depth of cut with a degree of step over, if that's your milling technique, then that's the tool for you in aluminium.
And the drills, the VDS, the solid carbide drills, I have seen stacks of these on my travels. Yes, this is aluminium, but it'll drill anything, Paul.
It will. The VDS is the standard go-to solid carbide drill from the Whittier stable. We apply it to virtually any material with fantastic results. It's obviously available with and without through coolant, from small diameters all the way up to large diameters, and it just performs very, very well.
You say how small and how big? How big?
So the smallest is 1 millimetre, 1.5 millimetre with through coolant, going up to 20 millimetre diameter. But then we have the other Whittier drill ranges which take over from there, which we'll talk about in a little bit.
Yeah, and some of the other products on there, some of the roll taps, the Whittier roll taps, very popular again.
Yeah, so in the Whittier stable, you know, they've got lots of different products, going from the solid carbide products, indexable products, even going through to the tapping stable, etc. So we can choose from a couple of different companies that manufacture products in the tapping ranges under the Whittier umbrella, both for aluminium, and you'll see later for the stainlesses and steels, etc.
You're fairly unique, really, at ITC, aren't you? You've got obviously a huge manufacturing facility, but equally you bring in factored products from, you know, from in this case Whittier and Big Kaiser.
Yeah, so I mean, ITC have been going for over 25 years. We've got our own manufacturing plant in Tamworth, producing solid carbide product, and then that's backed up by the brands that we're 8 UK agents for. So Big Die Shower, Big Kaiser, which is the tool holders as well as the boring equipment, and then Whittier with the indexable and solid product offerings that they have.
Sure. On the solids, obviously you've got a colossal range of your own, and obviously the Whittier's huge as well. So when you walk into an engineering company, we're looking at aluminium today, well at the moment. How do you go about, selecting the tool when you've got both stables?
A lot of it is about having the range of product in your kit bag, so you can assess the machine, work holding, as well as the actual, you know, the application at hand, and that will draw us up, you know, using our experience to select the actual tool. We're not just there to sell an ITC tool, we're there to sell from the whole of our product range. So we will actually give advice and probably find the best method with the kit available that we have.